In this module, I'll be talking about visualization of data. So at the end of this session, be able to illustrate sources of variability using box plot, dot plot, and marginal plot. Create multivariate chart to describe within and between subgroup variability. So where does these techniques fit within the overall big picture? So under the analyze phase, I think it's important that we look at things relative to visually and also conduct hypothesis tests. Right now, we're going to be focusing on what we might do on visualization. So that's what this chapter of Volume 3 talks about. If we look at the drill down of the analyze phase for the IEEE Lean Six Sigma roadmap, we'll see 7.3 talks about visualization and 7.6 talks about hypothesis testing. So if we go in and examine the drill down for this particular step, what we get is a decision tree. So at the left-hand side, we see visualization of data. That's 7.3.0. It breaks out if the output is discrete versus continuous in 7.3.5. So for the purpose of this section, we're going to be focused on the output that's continuous. Now, if you have continuous input, then what you'll see is you go up to 7.3.6, and then you can lead over to like a scatter plot. So that's if we got an X relationship to a Y. So that's a visualization that we'll be talking about later. What I'm going to be focusing on this time is the output is continuous and the input is discrete. So then if we come over and look at that, it comes out 7.3.12 and 7.3.14. Okay, so if we've got the effects, so if we got continuous outputs and we have inputs that are discrete, then the thing is we can lead to box plot, dot plot, or marginal plots, which are described in the chapter. If the input is discrete and we have a hierarchy relationship, then it can lead to a multivariate chart. Now what that might mean is, let's say we have we're looking at material, and all of a sudden we've got a dimension on a part, and we want to look at the variation across that particular part. So that has a hierarchy in relationship to parts, and then it's got between parts. So one way of presenting that information as a picture is a multivariate chart, and that's described and shown in the chapter. Now, what I think is really important is, again, starting with a 30,000 foot level metric. So we're tracking a 30,000 foot level over metric over time, and it indicates stability to it. We then have a probability density function. Now, you know that I'm big on probability plots, so I'd really have a probability plot here, but for the purpose of illustration, we're going to have a probability density function. And then let's say we've got specifications or values that we do not want to exceed on the upper and lower conditions. So the question is, what's causing this variability? So that's what we're really trying to do with this overall methodology, create visualization techniques that give an insight to relationships that we might have. We want to observe maybe differences between samples, variables, and so on. So in the 30,000 foot level chart, we may have several machines, or we may have several operators, or we could even have several different facilities. So all those could create variability that's affecting the overall response that we might have from a customer's point of view. So we would like to gain insight to that kind of variability, and then that could hopefully help us determine what we should do to improve the process. So in this module, we learned how to create and use box plots, marginal plots, and we also talked about multivariate chart.